Now that we have talked about properties of chords, we're going to talk a little bit more detail about angles that are formed when chords intersect. So an inscribed angle, let's see if I can squeeze this on the line for you. And again, there is a blank note sheet if you want to follow along. So an inscribed angle is an angle whose vertex is on the circle and whose side contains chords of the circle. So I wrote that vocabulary word in red because hopefully you can see the red, they look like rays on the segments. But they are intersecting your circle in two locations, so they could also be considered chords. Well, sorry, this part of it here would be considered a chord. And those two chords do form an angle. We can see it forms an angle right here. So that angle, is what we call an inscribed angle. The arc that is then formed by that angle, we can see in blue, hopefully right here, is what we call the intercepted arc. Intercepted arc. So inscribed kind of sounds like inside. That's how I remember what that is. And intercepted kind of sounds like intersected. So I think about the part of the circle that is intersected by that angle. Theorem 10.7 talks about how we can find the measure of an inscribed angle in a circle. So the measure of the inscribed angle is half the measure of the intercepted arc that it makes. So looking at that diagram, the red in this case is the intercepted arc. So the measure of that angle would be half the measure of that arc. So looking at some numerical examples here. In example 1, we have this. We're trying to find the measure of angle T on the circle. So hopefully we can see that this chord and this chord form angle T. And we can see that the intercepted arc there is 48 degrees. So to get the measure of angle T, you're going to take that 48 degrees and you're going to divide by 2. So the measure of angle T will equal 24 degrees. The second part of that example is asking us to find the measure of arc QR. Well, arc QR is out here. That is not an intercepted arc because it is not formed by an inscribed angle. We do have an inscribed angle, however, here, angle R is an inscribed angle. Since the measure of angle R is 50 degrees, we know that arc QT, which is the intercepted arc for angle R, would have to be 100 degrees. Okay? You may notice that, let me see if I can get a different color here. I'll just use red again. You may notice that this right here is a diameter because it's going right through P. So I'm just going to make a note that RT is a diameter. That becomes super important because that means this entire thing is 180 degrees. So if I know arc QT is 100 degrees, that means that the measure of arc QR is 180 minus that 100 degrees that we had. So that will equal 80 degrees. So a little extra step there, but hopefully that made sense for you. Looking here at example 2, they're asking you for a few different things. The first thing they're asking you for is to find the measure of arc RS. So let me highlight that arc. We can see that that is an intercepted arc of angle U. So kind of outline this. Hopefully you can see that that arc belongs to angle U. We know that the measure of angle U is 31 degrees. So if we double that, since we know the angle is half the measure of the arc, we're working backwards, so we're going to double that. We know the measure of arc RS is 62 degrees. The second thing they're asking us for is the measure, let me use the highlighter. The measure of STR. Okay, so angle STR, if I outline that, is here. So we can see that the intercepted arc is RS. Well, you hopefully can notice that that is the same arc that we just found, RS. So the intercepted arc is the same for both of these angles. So I know that the arc is 62 degrees. So if I cut that in half, that means the measure of the angle is going to be 31 degrees. So hopefully, seeing that outlined and highlighted a little bit, you notice that angle STR and angle RUS are congruent. Which brings us to theorem 10.8. It says if two inscribed angles of a circle intercept the same arc, then the angles must be congruent. This makes sense. If the arc is congruent, the angle that has made the arc should also be congruent. So looking down at example 3, now we're just naming two pairs of congruent angles. So there are a couple different options here. We have angle M and angle J. Both form intercepted arc KL. So angle J and angle M are congruent. The other option we have is we have angle K and angle L. Should really have two arcs there, which both form arc JM, the same intercepted arc. So we can also say that angle K and angle L are congruent. So we have two pairs of congruent angles in that figure. So now we're going to kind of put all this together, and we have a few examples here just to find the measure of either the specified angle or the specified arc. So now would be a good time to pause the video and try these three on your own quick, and then resume so that you know if you got them right or not. So in example 4, we are trying to find the measure of HGF, which is this angle here. The intercepted arc is 90 degrees, so the angle has to be half of that, so it will be 45 degrees. In example 5, we're trying to find the measure of arc TV. Well, the inscribed angle that forms arc TV is 38 degrees, so if we double that, we will get 76 degrees. And in example 6, they want us to find the measure of angle ZXW, which if you notice, angle ZXW forms the intercepted arc ZW, which also is formed by angle ZYW, which is 72 degrees. So this other angle ZXW will also be 72 degrees.